Okay, this is the last section in chapter 4, the medians, altitude, and perpendicular bisectors, objective 2, 3, and 4. Okay, this is 22 pages. It's a big packet. Okay, it's a lot in here. And this video may be a little bit long. Okay, this warm-up we're going to do in the class using the Mira. You remember Mira? Okay, so we do that in the class. Okay, so here's the last section of the chapter. Okay, and then all these three are in this pocket. That's why it's a big pocket. So first one is apply the definition of the median and the altitude of a triangle and the perpendicular bisector of a segment. Okay, the definition of the median and altitude of a triangle and the perpendicular bisector of a segment. Okay. All right, so here is the definition or the vocabulary. A median of a triangle is a segment from the vertex, one of the vertex, to the midpoint of the opposite side. The three medians of the triangle ABC are shown below in red. Well, this is black and white, but these are red lines. Okay, so from the A to the midpoint of BC, that's one median. From the B to the midpoint of AC, that's the other median. Here's from the C to AB, that's another median. So median is from the vertex to the midpoint of the opposite side. The altitude, on the other hand, of a triangle is a perpendicular segment from a vertex to the line that contains the opposite side. In an acute triangle, so this is a perpendicular segment. Okay, this is a midpoint. This is perpendicular segment. In the acute triangle, the three altitudes are all inside the triangle. So from the A, 90 degree to there, B, 90 degree to there, the C, 90 degree to there. Now, altitude means height, right? I don't know if you know this, but the meaning of altitude is a height. So if you remember, you learned how to get the area of a triangle, and you had to do base times height, and then you had to get the 90 degree line to get the height. This is what this is. The altitude is really the height of a triangle. Okay, in the right triangle, two of the altitude are parts of the triangle, because you're just looking for 90 degree from E to DF, that's the altitude. From F to ED, this is the altitude, okay? And only one of them is inside the triangle, from D to the EF, okay? So if it's a right triangle, two of the altitudes are the size of the triangle. And here is the obtuse triangle. Two of the altitudes are outside of the triangle and one is inside. So from this vertex 90 degree to this segment, you have to extend the segments to outside, and this is the altitude. From here, from this vertex, you have to extend this line because opposite side is this, but 90 degree from here is going to be outside the triangle. Only one that is going to be inside is the one opposite from the obtuse angle. From the acute angles, it's going to be outside. Okay, and the perpendicular bisector of a segment is a line or ray or segment. Line, ray, or segment, so it could be anything. That is a perpendicular to a segment at its midpoint. So it's 90 degree, and then it goes through a midpoint. In the figure at the right, L is a perpendicular bisector of JK. Okay, so it's of the segment, because talking about midpoint, you have to have an end, right? So perpendicular bisector, this could be the segment, line, ray, but the one that it's cutting have to be a segment, because you have to go through a midpoint. And in a given plane, there is exactly one line perpendicular to a segment at its midpoint. If this is the segment, there is only one line that is a perpendicular bisector to the segment. We speak of the perpendicular bisector of a segment. In such case, proof of the following. Okay. Alrighty, and practice for objective 2. We try some of this with a mirror in a class, so you don't have to do this right now, okay? But the yeah, I think it's better to practice in the class. Right. Objective 3. State and apply the theorems about a point on the perpendicular bisector of a segment and the converse. Okay, so this is objective 3. So the first one is, if a point lies on the perpendicular bisector of segment, then the point is equidistant from the end point of the segment. So if point A is on the perpendicular bisector, which is L, or BC, the distance from A to B and distance from A to C are equal. So we are trying to prove that these are the same distance. And the way to do that is to prove these triangles are congruent, because then these are corresponding sides of the congruent triangles. So line L is a perpendicular bisector BC, A is on L, and you have to prove AB equal AC. Okay, so by definition, the perpendicular bisector means this is 90 degrees, and also these are midpoint, and this is shared, right? So I think you can do the proofs, and then once you prove that these triangles are congruent, then you can do this equal this by CPCTC. Okay, so do this one, write this proof as a homework. And this is the converse. Okay, so if a point is equidistant from the end point of segment, so this is, let's say this is a random point, but if this happened to be equidistant from the two end points of the segment, then this point is going to be on the perpendicular bisector of that segment. That's what this is saying. So if AB is AC, then this line have to be a perpendicular bisector of BC. So here's the plan of proof. A perpendicular bisector of BC must contain the midpoint of BC and perpendicular to BC, and draw an auxiliary line containing A that has one of these properties and prove that it has the other property as well. Okay, so for example, draw a line, first draw a segment from A to the midpoint of X, midpoint X of BC. Then you can show that AX is perpendicular to BC, and if you can show that angle 1 is angle 2. Since these angles are corresponding parts of two triangles, first show that triangles are congruent. Okay, so here's the two things. What it's saying is that this point lies on the perpendicular bisector of a segment, right? So this has two things, because it's perpendicular and also it's a bisector, right? So then you have to actually prove that these are same lengths and this is 90 degrees. But in the proofs, you cannot prove two things in one proofs. So what it's saying is that assuming that this is the fact is that these are congruent, and you draw auxiliary line, making one of these, either this or this, true. So draw a line that is midpoint, and then you prove that it's 90 degrees, then you have proven this. Or you can draw a line that is 90 degrees from A, and then you prove that that's a midpoint, and you have proven this. That's what this is saying. Okay, so here it's saying, for example, draw a segment from A to the midpoint of X. So this is starting with this, and prove this. And then on the next page, there's another one that says, you start with 90 degrees and prove this. Okay, so we do both. Okay, so this one, I'm going to write the statement and then you give the reasons. Okay, so first, L, the line L is, the line L here. No, I'm sorry, I'm looking at a different one. All right, let X be the P on the page 3 and definition. All right, so I would say let X be, now don't worry about having to do a proof like this on the test. This is just to show you what it looks like, the proof for this theorem. Okay, let X be the point, the midpoint of BC. Okay, and this is Ruler postulate. Ruler postulate says that there is a midpoint for any segments, right? So it's saying that this is a midpoint of this segment. Okay, and then that means that segment BX is congruent to segment CX, and that's the definition of midpoint. Now, if you're not secure with how to use the definition, you should say that if X is the midpoint of BC, then BX is congruent to CX, because that's what the definition of midpoint is. Okay, right. And 3, draw segment AX, and through any 2 points there is exactly one line. All right, so I did these reasons. The rest I think you can do the reasons yourself. Okay, so for AX is congruent to AX, we are trying to make these triangles congruent, right? And 5, AB is congruent to AC, and 6, you got the BX and CX and AX, and so triangle ABX is congruent to triangle ACX. And 7, and we are trying to prove that this is 90 degrees. So angle 1 is congruent to angle 2, so these are corresponding angles, right? And after that you can say AX is perpendicular to BC, and here is the reason that it's, you have to think through what to put there. Okay, gotta think about that. It says if these are congruent and these are adjacent angles, then lines are perpendicular. What is that reason? And so AX, line AX or segment AX, doesn't matter, is a perpendicular bisector of BC. And and 10, then line of perpendicular definition. All right, and then A is on the perpendicular bisector of BC. And then this one is A is a point on line AX. Okay, so do the reasons here. And I think this is a little tricky and this is a little tricky, but I wanted to try. Okay, right. And here is the converse. Oh, this is alternate proof. Sorry, no converse. So this one, you start with perpendicular line, and then we are trying to prove that BY is CY. Okay, so this is a little longer one. Draw altitude to BC from A, meeting BC at point Y, and this is through any 2 points. There is exactly one line, right? So this is Y. Okay, so that's the auxiliary line. Okay, and then 2, A segment AY is perpendicular to BC. And why is that? Because it's altitude, right? If it's altitude, then it have to be 90 degrees. So let's go to this definition of altitude. Okay, and then 3. No, you want to say that these are congruent, right? Because that's what we're going to use. Okay, so angle AYB and angle AYC are right angles. And this one, you can say this is definition of perpendicular lines. The lines are perpendicular, then angles form the right angles. Okay, also if the lines are perpendicular, then angles form the right angles. That's the definition of perpendicular lines. Okay, and so you want to say, by the way, so you have this side shared, right? And this is 90 degrees, and then these hypotenuse. So we're going to go with HL here. Okay, so you have to say the right triangle statement. So triangle AYB and triangle AYC are right triangles. And that's the definition of right triangles. I'm very worried about using all these definitions and you're getting it wrong. But if you don't want to use a definition, if the triangles have one right angles, then the triangles is right triangle. Okay, right. 5. So we said this is R, right? R. Now let's go with H. So segment AB is congruent to segment AC. I think you can do the rest of the reasons. So I'm gonna leave it there. And then you can do leg. Segment AY is congruent to segment AY. And oh no, here's just 6, right? And then 7, I think you got the 3, so you can say triangles are congruent. Okay, so then we are trying to make this the same length. So BY is congruent to CY. And then 9, AY is perpendicular bisector of BC. Okay, so it's just definition of perpendicular bisector. Definition perpendicular bisector is the line is perpendicular to the line and then it goes to a midpoint. We just proven that it's a midpoint, so that's a perpendicular bisector of BC. That's definition perpendicular bisector. And then 10, A is on the perpendicular bisector of BC, and A is a point on AY. Okay, again, so you just do these reasons. Again, you don't have to worry about producing this proof on your own. You know, this is just to show you the proofs. All right, practicing using theorems 4.5 and 4.6. So again, just to recap, 4.5 is if the point is on the perpendicular bisector, then it's equidistant to the end point of the segment. That's 4.6. And 4.5 is if the point is I'm sorry, that's the 4.5. If the point is on the perpendicular bisector, then it's equidistant to the end points. And this one is if it's equidistant to the end point, then the point is on the perpendicular bisector of that segment. So those are converse of each other. Okay, so you try these. Okay, homework. Right, this is getting long, but here is the objective 4. Right, so objective 4 is state and apply the theorems about a point on the bisector of an angle and their converse. So the objective 3 was perpendicular bisector. This is the angle bisector. Okay. Right. So theorem 4.7 is that if the point lies on the bisector of the angle, it's equidistant to the side of the angle. And the converse is if the point is equidistant to the side of the angle, then it's on the perpendicular bisector. Okay, so as you can see, you are making these triangles congruent so that we can say that this is angle bisector. So you are trying to prove that if the line is on the perpendicular bisector, so you start with these angles being congruent, right? And then I'm sorry, angle bisector. And then the distance by definition is 90 degrees to the line, because that's the shortest distance from the point to the line, right? So you start with two angles, and this is shared, so it's angle side. Then we can say that these are the same distance. So that's 4.7. This is getting long, so you don't have to write this. This proof is actually in the textbook. And then this one is the converse. So the converse, you start with the point is on here, and these are 90 degrees, right? And then it's equidistant. So these are already congruent. And also, so the px is py, and this is shared. And you want to prove that these are congruent, right? So these are 90 degrees. The hypotenuse is shared. The leg, this is HL. Okay, we are not going to do this one. I think you can write it anyway. So that's trickier than the perpendicular bisector one. So let's just do this practice and then we are done. We have practice through 11 and the rest we do in the class. Okay, it's a lot to do. Anyway, I think you can do all this for homework. Okay, these are not hard. This is just to understand what the all these terminologies that you're learning are. Refer to ABC and name each of the following. All right, so median of ABC. With median was the midpoint, right? Midpoint of segment. So which one is this? The altitude is the 90-degree one. So which one of these? And a bisector of an angle ABC. So bisector, you can do this. It's not bad. And draw XY, label the point Q, and select the point P, equidistance from statement. Okay, so I think you can skip this one. Skip. Right. And given the triangle DEF is isosceles with DF and EF, and FX bisects this angle, would the median drawn from the same segment of those? All right, so do this one. Okay, and what kind of triangle has 3 angle bisectors and also altitude and medians? What kind of triangle has 3 angle bisectors that are also not? All right, I want you to think about this as a homework. And I think since it's getting long, we're gonna do the rest in the class. Okay, all right, and then make sure you do the survey.